दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, the reactions involving different type of alcohol or the chemical properties of alcohol we have discussed. That mega, a source of mega horsepower ODC, MEGA-ASHP ODC. Mega is the reactions involving the active hydrogen atom, cleavage of OH bond. M, reaction with metals. E, esterification reaction. Z, reaction with the Grignard reagent. A, reaction with acetyl chloride. All these reactions will be given by primary, secondary and tertiary, and the order of reactivity is primary alcohol is more reactive than secondary alcohol, more reactive than tertiary alcohol. Then coming to reactions involving OH group, the cleavage of CO bond is a source of horsepower, ASHP. A, reaction with ammonia. S, reaction with constant sulfuric acid. H, reaction with halo acids. P, reaction with PCl5, PCl3, PBr3, PI3 and SOCl2, the thionyl chloride. In all the reactions, all the three type of alcohols will give this reaction. The order of reactivity will be 3 degree more reactive than 2 degree more reactive than 1 degree, because in all the reactions involving cleavage of CO bond forms a carbonium ion as a reaction intermediate. Tertiary carbonium ion is more stable than secondary carbonium ion, more stable than primary carbonium ion because of the plus I effect. That carbonium ion is more stable, is more readily formed. Hence, tertiary alcohol forms tertiary carbonium ion more easily than secondary alcohol forms secondary carbonium ion. Then primary alcohol forms primary carbonium ion more easily in presence of a proton or a presence of an acid or in presence of a catalyst at a high temperature. And these reactions are the nucleophilic substitution reaction. The carbonium ion is formed the reaction intermediate, then the carbonium ion is attacked by the nucleophile of the other part of the added reagent, producing the substituted product. Then comes the reactions in which alcohols differ. They are the reactions involving the carbon atom, primary, secondary, tertiary. In primary carbon atom, there are 2 active hydrogen atoms, 1 alkyl group. In secondary alcohol, there are 2 alkyl groups and 1 active hydrogen atom. In tertiary alcohol, there are 3 alkyl groups. So here plus I effect thrice, there plus I effect twice, there the plus I effect once take place. So the positive charge upon the carbon atom decreases and the reaction. So in this there are 2 hydrogen atoms in primary alcohol, 1 in secondary and no hydrogen atom. Hence the structurally they differ. So all the reactions involving the type of carbon atom and alkyl groups, they distinguish the 3 alcohols. So the alcohols are distinguished primary, secondary, tertiary from one another in the reactions ODC. O, oxidation. D, dehydration, dehydrogenation. C, the reaction with chlorine in presence of sodium hydroxide or potassium hydroxide. So this is very easy for you to remember the properties of alcohol. Mega, a source of mega horsepower ODC. Now we will discuss now the reactions involving active hydrogen atom, mega reactions. So we will discuss now the reactions involving the active hydrogen atom. Why I am calling active hydrogen atom? Here that is this is alcohol COH. So there is a drift of electron take place towards oxygen atom. Oxygen atom gets delta negative charge, hydrogen atom gets delta positive charge. So this bond is polar, this bond is partially polar and ready to cleave, and this reaction. So reactions, so order of reactivity reactivity is 1 degree more reactive than 2 degree more reactive than 3 degree, and the code I have given you is MEGA. The reactions involving reactions with metals, esterification reaction, G reaction with Grignard reagent, A reaction with acetyl chloride. So now first reaction is reaction with metals. Reaction with active metals. So I am using the active metal because the metals, if you go to the periodic table, along a period of the periodic table, the electronegativity increases, down the group electropositive character increases. Hence the elements belong to group 1 and group 2, they are very highly electropositive. These metals are called as active metals. But if you come to transition elements, the B subgroup element belong to D block, they are strongly metallic. Metallic character is there, but they are less reactive than the alkali metals and alkaline earth metals. So all these metals are highly electropositive, and the hydrogen atom is positive. So they are, if you go to the electrochemical search, the lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, barium, strontium, zinc, iron, aluminium, these elements are above hydrogen in the electrochemical series. They are more electropositive than hydrogen, so they can displace hydrogen because those have metals which are more reactive that displace hydrogen, the active hydrogen from the molecule. So it easily reacts. So reactions involving this. So all the elements, who are the elements? The elements are sodium, potassium, all these alkali metals, and alkaline earth metals, magnesium, calcium, and aluminium. Also they are the electropositive metals. They substitute the hydrogen atom. So the alcohols, when you come to this, it behaves like water. If you take water, HOH, we take water and treat this with sodium, this forms a sodium hydroxide plus hydrogen, and this reaction takes place violent. So this reaction takes place violently. So there is a lot of sound is produced, and light is produced. You see a light. That means the water, they had this in water, this hydrogen atom delta positive, this hydrogen atom delta positive, oxygen is delta negative. So the hydrogen atom is substituted by the sodium atom to form sodium hydroxide and nascent hydrogen. Then hydrogen combine, they form the hydrogen molecule. If we come to alcohol, ROH, we take ROH alcohol, treat this with sodium, metallic sodium or metallic potassium or aluminium or zinc or calcium, then this hydrogen atom has delta positive character and delta negative character. So this sodium will displace hydrogen and form RONA minus and Na plus and liberate the hydrogen gas. So this is called sodium alkoxide. This is called as sodium alkoxide, RO minus. This is alkoxide ion, RO minus ion, and this is Na plus ion. Just like NaOH, this is sodium alkoxide. It is a base. Sodium hydroxide is a base. Here this sodium alkoxide ion is this alkoxide ion, RO minus. Alkoxide minus, OR minus, RO minus, alkoxide ion is strongly basic. Strongly basic. This alkoxide ion is strongly basic. So these metals react with alcohol to produce sodium alkoxide and hydrogen. Potassium will form potassium alkoxide hydrogen. Calcium will form calcium. Aluminium will form aluminium alkoxide. And this sodium alkoxide or alkoxides are very good starting material for the preparation of ether. This alkoxide is used, when this alkoxide is used with alkyl halide, it forms a ether. The reaction of sodium alkoxide with ether is called as Williamson synthesis. You will read that is Williamson synthesis. You will read that Williamson synthesis. All this. So this is a reaction take place. So this reaction, in this reaction we say the hydrogen atom has acidic character, but alcohol is a neutral. I will explain you that. Here the alcohol, this hydrogen atom is an acidic hydrogen atom and is replacing sodium, forming sodium alkoxide, and the sodium alkoxide is alkoxide ion is a strongly basic, it's a Bronsted base, those which have a strong affinity to accept proton are called as Bronsted base, and those have the ability to donate proton, they are called as Bronsted acid. Lowry-Bronsted acid, so these are Lowry-Bronsted base, strongly basic. It does not allow the H plus to go. I will come to that and explain you this. Now the same reaction will take place also with the metals and metal hydride. Metal hydrides also, they react similarly. If you take alcohol ROH and treat this with the sodium hydride, Na plus H minus, sodium hydride. So this hydrogen is replaced by whom? By the sodium. So this forms, this gives the reaction to H, RO minus, Na plus, sodium alkoxide, plus we get the hydrogen. This hydrogen form H2 and Na comes here, sodium alkoxide. So this sodium alkoxide produced is used to prepare ether in Williamson synthesis. Similarly, this alcohol ROH also reacts with sodium amide NaNS2. Sodium NaNS2, NS2 is minus, Na is plus. Here hydrogen is delta positive, oxygen is delta negative. So this reacts, so this sodium replaces the hydrogen, displaces the hydrogen, it forms sodium alkoxide Na plus and NS2, NS3 ammonia. So these reactions, they say that the hydrogen atom alcohol has a delta positive charge, can be substituted by the metal atom. And this is a very important reaction. This alkoxides, this is a method for producing alkoxide, because the who is goes, these are the gas, hydrogen gas will go away. And one more thing, when you take this alcohol, since alcohol produces what? The alcohol produces the nascent hydrogen. So this alcohol produces nascent hydrogen, the mixture of this alcohol and sodium, mixture of alcohol and sodium is a strong reducing agent, is also a strong reducing agent. I have talked to you while discussing the preparation of alcohol, there is a reduction of carbonyl compounds. There we can use this alcohol plus sodium, because the sodium displaces nascent hydrogen from alcohol readily, and that can be used as a reducing agent in the reaction medium. And thus reaction is called Bauwelt-Blanc reduction, the reducing agent. So there is a very strong reducing agent, mixture of alcohol and sodium. Now this sodium alkoxide, when we take this sodium alkoxide and treat this with alkyl halide, it forms ether, it produces ether. The ether is very easily produced by this method, and this reaction is called as Williamson synthesis. So in your entrance exam, the by Williamson synthesis, the compound produced is alkane, alkyne, alcohol, ether. The answer will be ether. The Bauwelt-Blanc reduction is used, the reducing is used in Bauwelt-Blanc reduction is lithium aluminum hydride, sodium boron hydride, and sodium and alcohol. So there the answer will be sodium and alcohol. Entrance exam questions will never come from the sky, or will never come from the sea. It will come from your our topics when you are reading. So while reading, if we understand what questions can come from this place, and if our mind is a wonderful receptor and it goes on receiving things, if you allow the mind, activate the mind accordingly, and so that answers will be with you. So all these reactions will tell us what? Alcohol exhibits acidic properties. No alcohol though hydrogen, it contains an active hydrogen atom, alcohol is not an acid. Alcohol is neutral. Alcohol is neutral. This I have discussed to you while discussing the resonance. So we say that alcohols, this alcohol ROH, so delta positive, delta negative. So this dissociates to produce RO minus and H plus ion. So this reaction is a very slow reaction, and if you take the equilibrium constant K ROH, the equilibrium constant of this dissociation constant of alcohol ROH becomes a concentration of RO minus and concentration of H plus into concentration of ROH, and this comes to around 1 into 10 to the minus 18. The dissociation constant of alcohol is in the order 1 in 10 to the minus 18. Whereas if you take water, HOH, this dissociates to form H plus and OH minus, and this concentration of this Kw comes here, concentration of H plus into concentration of OH minus into concentration of water. This comes in the order 1 into 10 to the minus 14. So here it comes to 1 in 10 to the minus 14, and here it comes to 1 in 10 to the minus 14. So dissociation constant of alcohol is much less than the dissociation constant of water. That means the hydrogen ion concentration present in alcohol H plus is much less than the hydrogen ion concentration present in water. Or the hydrogen ion concentration, the H plus ion concentration given by water is more than the given by alcohol. Hence, alcohol is more neutral. Alcohol is less acidic than water. Less acidic than water, or water is more acidic than, or you can say alcohol is more neutral. Alcohol is more neutral than water. Alcohol is more neutral than water. So in organic reactions, whenever we want a neutral medium to carry out a reaction, we make the medium alcohol, alcoholic medium, and conduct the reaction. Because in alcohol there is strong intermolecular force of attraction because of intermolecular hydrogen bonding, and because of that they remain in an associated state. Hence this neutral character of alcohol, a very good medium, and it has very high boiling point. It has a very high boiling point because of intermolecular hydrogen bonding. Hence this gives us a very good solvent character this alcohol has. Hence it is used as a very good neutral solvent. Wherever we want a neutral solvent, we choose the alcohol as the best. Now then comes MEGA. We will come to second reaction, is esterification reaction. Second reaction is E, is esterification reaction. Means what? Formation of ester. This is esterification reaction. When an alcohol is treated with carboxylic acid, when an alcohol is treated with carboxylic acid, when an alcohol, we take an alcohol and treat it with carboxylic acid, the hydrogen atom of the alcohol is substituted in presence of concentrated sulfuric acid, undergoes a reversible reaction to produce ester and water, So this reaction is called, it forms an ester, hence this reaction is called as a esterification reaction, and the reaction takes place in presence of constant sulfuric acid or in presence of dry anhydrous HCl. This can also take place in presence of anhydrous HCl gas. This reaction can take place in presence of anhydrous HCl gas, or take place in presence of constant sulfuric acid. Generally, the constant sulfuric acid is chosen because HCl is susceptible for reaction with alcohol, hence this is always chosen as a concentrate sulfuric acid. So what we will say, when an alcohol is treated with a carboxylic acid, undergoes a reversible reaction, or acid catalyzed reversible reaction, undergoes an acid catalyzed reversible reaction to produce an ester, called as esterification reaction. When you take an alcohol, ROH, we take alcohol, we treat this with a carboxylic acid, RCOH, and we treat this with in presence of concentrated sulfuric acid. What is concentrated sulfuric acid? Is a dehydrating agent. Is a very dehydrating agent. So what happens? This bond breaks because the reaction involving mega reaction. Mega reaction is the reactions involving whom? The hydrogen atom. Very easy for you. What will go in this reaction? The hydrogen atom will go. Why? It is a mega reaction. What is mega reaction? Reactions involving active hydrogen atom. There is no question of thinking of anything else go. Then who will go? And this bond of alcohol will treat. And we get here RCO. RCOOR. So this is the alcohol part, this is the acid part, and we get here water. So this is the ester we get. So this is always this is a reaction taking place. So what is coming out? The water is coming out. So concentrated sulfuric acid is a strong dehydrating agent. One molecule of concentrated sulfuric acid can absorb 5 molecules of water very easily, and the reaction is highly exothermic. Those of you students, you have done your practical class, you will do. The moment you take concentrated sulfuric acid, add a drop of water, immediately the temperature of the test tube will increase. The reason because this concentrated sulfuric acid is a strong dehydrating agent, it absorbs water molecules. So the hydrogen bonding present inside the water molecules, they undergo rupture, and those bonds they break. And because those bonds break, those bond energy they get liberated, and you get a lot of heat. So the test tube gets heated by adding a drop of concentrated sulfuric acid to water. So this concentrated sulfuric acid is a dehydrating agent, and hydrogen atom of alcohol and OH group of carboxylic acid, they react to produce. Suppose you take ethyl alcohol, CS3, CS2, OH, CS3, CS2, OH, and we treat this with acetic acid, CS3, COOH, acetic acid. This is ethyl alcohol, this is acetic acid. What will happen? The hydrogen atom of alcohol will come out, and OH group of carboxylic acid will react to produce CH3COOC2H5 plus water. This is ethyl, C2H5 ethyl, and this is acetate. So the product is ethyl acetate, and this is a reversible reaction. This is a reversible reaction. This reaction is called esterification reaction, and is a very good method for preparation of ester. Now this reaction I have taught you while teaching alcohol. Just preparation alcohol, we have used this reaction as a preparation of alcohol. What we have done? Hydrolysis of ester. Hydrolysis of ester. When an ester is treated with a dilute mineral acid, undergoes hydrolysis to produce the carboxylic acid and alcohol. Carboxylic acid, alcohol, which is reversible acid catalyzed, because the acid here, concentrated sulfuric acid, is used as a catalyst. It is not taking part in chemical reaction, and it is catalyzing the reaction. So it is an acid catalyzed reversible reaction. When you will read chemical kinetics, your sir will teach you it is a first order bimolecular reaction. Say pseudo-molecular reaction. He will call pseudo-unimolecular reaction. So it is a molecularity is 2 and order of reaction is 1. In first year you have read the chemical equilibrium chapter. There they have taught you in homogeneous liquid medium the reversible reaction. See this one reaction you are reading in preparation property of alcohol. This already you have read as a property preparation of alcohol. This you have done in chemical equilibrium. This you will do in chemical kinetics. Again, when I will teach you preparation of ester, this is a preparation of ester, and when I will teach you carboxylic acid, this is a property of carboxylic acid. So where the question of remembering comes, at one place, if you open mind, if you study the reaction and understand what you are reading and what you are writing, then my children, it will not have to remember anything. You go on forgetting, you will be bring. So more you forget. That's the reason I always tell in chemistry, the more you forget, more you remember. More you forget, more you remember. So when a alcohol treated with carboxylic acid in presence of concerned sulfuric acid undergoes an acid catalyzed reversible reaction to form an ester and water. And this reaction is acid catalyzed reversible reaction. And if you want a forward reaction, if you go on increasing the concentration of alcohol, the concentration of ester will be increasing. If any one of the reactant you have read in your chemical equilibrium chart, it is under a chemical dynamic equilibrium. If we increase the concentration of any one of the reactants, then the amount of product produced will be more. So this is a esterification reaction, and alcohols form ester when the H of alcohol react with OH of carboxylic acid to produce the water molecule, and remaining part is ester. Then third reaction is GRE, that is a reaction with Grignard reagent. So I have told you this Grignard reagent is a gateway of India in organic chemistry. So this is alkyl magnesium halide. This is alkyl magnesium halide. That is what is this? This is a carbon atom. Is a carbon atom, and this is a magnesium, and this is X, the halogen, where X can be chlorine or bromine or iodine. Generally we use bromine or iodine, alkyl magnesium bromide or alkyl magnesium iodide we use. So here the carbon atom is in sp hybrid state. This is in the sp hybrid state. So this is sp hybrid state. So what happens here? Drift of electron. So electronegativity of magnesium is 1.2 and carbon is 2.5. So always there is a drift of electron take place towards carbon. It's a linear molecule. It's a linear molecule. So this carbon atom gets delta negative charge and magnesium atom gets delta positive charge. So in Grignard reagent, R is delta negative and magnesium is delta positive. So this is what? A carbanion. This I have taught you while teaching you the preparation of alcohol is a carbanion. So Grignard reagent is a source of carbanion, or the Grignard reagent is a precursor of carbanion. So now that means in Grignard reagent we have the alkyl group is a negative charge, negatively charged, delta negative charge on the alkyl group. Now what we are doing? We are going to study the reaction of Grignard reagent with alcohol. So this is the Grignard alcohol, ROH. This is ROH. We are treating with Grignard reagent RMG, Br, say alkyl magnesium bromide. And then what here? H is delta positive, oxygen delta negative. Here R is delta negative, magnesium is delta positive. Then what will happen? This H plus and R minus. So this R minus will attract the H plus. Alcohol wants to leave H plus, and what is the medium? And the medium is always a dry ether medium. The Grignard reagent is always used as a dry ether medium. And we get as alcohol alkane. It forms alkane plus Mg OR Br. So Mg is bonded to now OR group, alkoxy group, and bonded to Br, MgOR Br. So you get this, and you get the alkane is produced. So this is a method for preparation of alkane. We have studied when you will study alkane, that RDWCH, then H hydrolysis of Grignard reagent is a method for preparation of alkane. So there, this is the method alkane is produced. So this reaction is a very, very specific reaction. This reaction is a very, very specific reaction. They react this way to produce this alcohol. So the order of reactivity is primary alcohol more reactive than secondary alcohol more reactive than tertiary alcohol. I will tell you how this reaction take place next class. Now, in the next comes A. What is this? Reaction with acetyl chloride. The next reaction, MEGA, is a reaction with acetyl chloride. So what is this? This is a chloro derivative of acetic acid. So this is acetic acid, CS3, CO, OH. This is acetic acid. From acetic acid, when you remove OH, we get CS3, CO. This CS3, CO. So this is acetic acid. Acetic acid. We are removing OH. So minus IC acid. Minus IC acid plus the bond is free YL, so this is called acetyl. So once you know this, why is called acetyl? Because this is acetic acid, we are replacing the OH group. So acetic acid minus IC acid, as it lost its acidic character, and one of the bond is free, so YL, acetyl. So acetic, this is a acetyl chloride is used for acetylation. Acetyl chloride, reaction with acetyl chloride is CS3 COCl. My point is, I don't want my students to remember anything. They should derive themselves what is acetyl chloride. Now, if we take alcohol ROH, we treat this with acetyl chloride CS3 COCl. CS3COCl. What is happening here? There is always a drift of electron towards chlorine atom because of chlorine is more electronegative, and there is always a drift of electron towards oxygen atom because of the pi bond, and this carbon atom has always a delta positive charge. This is the structural property of acetyl chloride. And what is this? H. So H plus and OR minus. So because here positive charge is there, so this OR minus alkoxide will be having a tendency to go to whom? To go to carbon. Because the carbon atom has a delta positive charge, it will have a tendency to attract a negative group. And here is a nucleophile who? OR minus is a nucleophile. The carbon atom attracting. And what is hydrogen? Hydrogen has a delta positive charge. And what is chlorine? Chlorine is a electrically negative. So H plus has a strong tendency towards chlorine to attract, and this carbon atom has delta positive charge, wants a negative group towards it. So this RO minus is negative. So this RO minus is negative. Alkoxide is negative. So this alkoxide will go there. So we'll get the reaction here. Now what? We'll get CS3 CO remains, and who came here? OR, and what the product is produced? HCl. So we get an ester, we get an acetic ester, we get an acetic ester and HCl. Suppose we take ethyl alcohol, say we take ethyl alcohol, CS3, CS2, OH. We take ethyl alcohol and treat this with acetyl chloride, CS3, COCl, acetyl chloride. What is this? There is drift of electron towards this. Chlorine has a delta negative charge. There is a drift of electron towards oxygen. This carbon atom has a delta positive charge center, and here in this hydrogen atom has delta positive charge and is ethoxide ion. So this has a tendency to go there. Hence the product is produced here. We get the product as what? CS3CO, and OC2H5. We got ethyl acetate plus HCl. So what is this? Who is produced? HCl is produced. What is HCl? Is an acid. We want the reaction to take place. So if you go on removing HCl from this, then what will be happening? The reaction will be faster. So to carry out the reaction, we take a medium of sodium hydroxide. That's the reason we take a medium of basic medium. The reaction is more useful, a basic medium. So when an alcohol treated with acetyl chloride in presence of sodium hydroxide undergoes acetylation reaction, this reaction is called acetylation reaction to produce an ester and liberate HCl gas. This reaction, why it called acetylation reaction? So this is our alcohol part. What is this? This is alcohol part. To alcohol, who is used? Acetyl group is used. To alcohol, who goes to alcohol molecule? To the alcohol molecule, who goes? Acetyl group goes. So since acetyl groups enters into the alcohol part, hence the reaction is called acetylation reaction or acylation reaction. Suppose you take a test tube, we want a test tube, and we take here alcohol, we take alcohol, we have taken alcohol. To that what we will do, we will add the acetyl chloride. To that we will add acetyl chloride and make the medium sodium hydroxide. Then what reaction will take place? What will happen? So in this you will get what you get? You will get an ester. What product you will get? Ester. And who will come out? HCl gas will come out. HCl gas will come out. So this reaction is used to test for alcoholic group. Test for alcoholic group in a molecule. If a group contains alcoholic group, then there is a very good test for alcohol. Why? HCl gas will come. It's a colorless gas. If you take a glass rod dipped in ammonium hydroxide, if you take a glass rod dipped in ammonium hydroxide and show here, if you take a glass rod dipped in ammonium hydroxide, then this ammonium hydroxide will react with HCl, produce a white fumes. This will produce what? This will produce white fumes. Copious fumes. They call these fumes as copious fumes. COPIOUS. Copious fumes. You get a large concentration of copious fumes and you get a fruity smell in the test tube. So many often children, when you will be appearing your practical viavos, they will go, which group is there? Alcoholic group is there in a practical. They will ask you, how do you test for alcoholic group? So we take an alcohol, add acetyl chloride and a few drops of sodium hydroxide and warm. On warming, the reaction take place. If it produces a gas, HCl gas, then show a glass rod dipped in ammonium hydroxide. This will form dense white fumes due to formation of ammonium chloride vapor, and the liquid inside the test tube will give you a fruity smell. The test of ester, smell of ester is a fruity smell, so presence of alcohol. So this is your mega reaction, and this reaction is acetylation reaction. We will read again this reaction as a property of acetyl chloride, acid derivative. We will read this reaction is a preparation of ester. See, preparation of ester, you will read property of acetyl chloride, you will read, and practical you are reading test for alcohol. So once you digest here at 3 places, you need not remember. So you need not remember organic chemistry, only go on understanding and learn to understand, and understanding will give you knowledge, and your knowledge will give you the capsules of wisdom that is with you. Whenever a question comes in the exam or in a viavos, you will very beautifully you can answer. Thank you very much for listening this. So you can subscribe our channel by pressing the bell icon, so that whenever you are uploading a next class, it will be coming as a notification to you. Thank you very much for subscribing and reading with us in our channel.